Hello everyone and welcome to our session on creating a visualization that would make Edward Tufte proud. While I can't speak for Tufte, I can say that today we will be recreating one of his more well-known visualizations and a personal favorite of mine, the New York City weather from 2003, where he visualized the range of temperatures and amount of precipitation in the city from that year and superimposed some contextual information to provide even more richness to his plot. This is a very high-touch visualization, and we have a short time here together today. So our goal is to simply get data onto the charts and speak to some of these fine-tuned aesthetic changes along the way. We already have our data curated and ready to go, so let's go ahead and dive right in. I have a little bit of code. This is just to perform some data pre-processing. You can find these data online. Weather for almost every city in the US is publicly available. So I've parsed and cleaned a little bit of this data for us to extract the meaningful or the useful portions that we'll be using. And specifically, we'll be using this precip data frame and this temperature data frame. But let's go ahead and just focus on one at a time. I've also extracted just a few colors from this from Edward Tufte's visualization, which I'll share with you in just a moment. But here's the data that we're working with. We have temperatures up here on the top. Specifically, we're going to be looking at the daily mins and maxes from every day in 2003 for New York City. We'll be looking at the historical minimum and maximum, so that's across all years of weather data that we have. This specific data source goes back to 1939. The data is a little spotty the further back we go, so I've interpolated it before performing an aggregation and then lifting it into the same index right as our daily mins and max. Then we have our normal min and max. This is simply the average of every month, or regardless of the year. And so you can think of the historical min and max as kind of an upper and lower bound, or range, across all the years. And then our normal min and max is an average, right, instead of a range. But let's take a look at the visualization we'll be recreating today. This is Edward Tufte's New York City's weather in 2003. You can see there are a lot of very high finishing touches here. Specifically, the setup of the axes. Right, we have two axes here, and we are looking at one plot for temperature and a second plot for precipitation. The things that will be tricky to do is one, setting up these ticks and formatting everything correctly. There will be a lot of fine-tuning there. Two, aligning this title will actually be surprisingly tricky, and I'll get to that later. Three, we have a lot of aligned text here, and this text alignment has to be very carefully placed because we want to place, say, a bold title, and then right below it we need to place a subtitle or a description. Same thing with this title down here. We need to place our text very precisely, and so we'll be exploring some ways that we can do that in Matplotlib. Taking a closer look just at the temperature axes here on the top, we can see that this is a bar chart, and we're looking at the red bar is the actual high, what he refers to as the actual low and the actual high. So that's our daily min and max. Then there's the normal range, which is our normal min and max, what we would expect based on all of the historical data, just through an average. And then we have our record low and record high, and that's our historical min and max. So this will be a chart with 3 layers of bars on top of it, where the daily min and max is the one in the forefront. Then for our precipitation, we can see that we're looking at cumulative monthly precipitation. And so we'll need to make sure that instead of taking an aggregation of these data, we'll want to take the cumulative sum for our precipitation per month. Right now, our precipitation data is just in a daily format, so we'll have to do a little bit of transformation there. Then we have these horizontal lines mapped over the cumulative sum. And this is the normal. So what I'm going to do is I'm going to just assume a little bit that by normal, Edward Tufte meant the same thing that he meant in the normal above, where we take all of the years or every year's worth of data, and then we find the total volume of precipitation from each month from each year, and then we aggregate just across all of the months regardless of the year that we're in. And so those are most of the things I want to point out. We can see that once I get a default Matplotlib chart going on, we will be nowhere close to the finished product. So let's dive into some code and start making some Matplotlib work for us. The first thing I'll want to do is set up just my figure and axes, and I'll call this my temperature axes and my precip axes. And we'll go ahead and create subplots here. I know that these will actually share their x value, so I'll go ahead and share x equals true. They are vertically stacked, so we need 2 rows. I'll just specify 1 column there, and we'll need show. So this is the default, right, Matplotlib chart that we'll be working with. Clearly, we have a lot of work to do. The first thing that I would probably want to do, I don't usually start with aesthetics, but I think just a few aesthetics can really motivate us for taking some large steps closer. And so what I'll do here, I'll reach into RC parameters. This should be figure, and I want to say this is either color or face color. Again, I'm doing this all kind of off the top of my head here. And so this background color for the palette should be the color for the figure, and it seems like it might be face color here. Okay, so we have the background color. We'll also need to apply that color to our axes. Let's see, axes should have a face color as well. Okay, and then looking back at the visualization, we have those colors. The background color is good. I think we're good to just jump right into adding the bars. Once we add the bars, we'll worry about sprucing up things like the X and Y axes themselves across both charts. So let's go ahead and plot the bars because that'll get us another major step closer to where we want to go. So we'll start here, just looking at our precipitation data, our temperature data. We know that we want 1 bar for each date, and then we'll want a bar that shows whose bottom shows the daily minimum and whose top shows the daily maximum, and then we'll kind of repeat that pattern for historical and normal. So let's go ahead and do just that. So this should be our bar. We'll take our temperature data, take the index there, and then we'll take our temperature, and this should be our historical. I'll plot them layered, right? The first thing that you add onto a chart will be layered. Just looking back at our data, historical min. And this should be our max, so that's our top, and then our min, so this should be our bottom. And then the color will be our palettes here, and we'll grab our record range. Probably could rename that to historical range, but not going to be too bad. So there's one thing that we do need to spruce up here. Clearly this is not right. The bottom, which we failed to specify, should be the min. So let's go ahead and take a look at this now. The bottom looks good, but the top of our chart is definitely off. I don't think it ever got to 150 degrees in New York. So the problem here is that this is the height, not necessarily the top. So what we need to do is just a small transformation. Since we're offsetting our bottom by the minimum, we will need to account for that when we calculate the height of each of these bars. So go ahead and drop that in. Let's take a look now. Okay, that's not looking too bad. I think we'll also need to spruce up the edge color here. The color is the face color of the rectangle on each bar, whereas the edge color, right, is a line that goes around each rectangle. So we can go ahead and add that edge color, and this will help our bars kind of blend together. We could also remove the edge color and expand the width of each of these bars, but I think we're getting in the right range. This is starting to look correct when we pair it up against, right, the original visualization. So next thing I'll do is I'll go ahead and I'm going to actually not plot the red bars, but the darker color, the normal range here. And I can just copy all of the code that I already have, and we'll just swap out historical for normal here. Just like that. Good, good. And this should be normal as well. That's good, that's good. And then we'll also need our color, which will be our daily range here. Or sorry, not our daily, our normal range. So we'll just swap out record for normal. Just like that. All right, let's take a look. we also need to add on the red bars now. So the normal range, it's looking right to me. One thing that I'll fix just very quickly because it's bothering me, we'll just tighten up the margins on the x-axis there, and then we'll set our y limits. I'll just grab those manually. Since we're doing a recreation, I don't necessarily want to rely on just some automatic placement of my y min and max. So just go ahead and grab these. It's -20 up to 110. So we'll just quickly do this in Matplotlib, -20 up to 110, just like that. And then we should be okay to power forward, power ahead, and swap our normal out for our daily. And this is looking actually quite good to me. This looks very close to a recreation of what we've seen. One thing that is kind of off here, I'll need to change the ratio of my temperature axes. In the Edward Tufte visualization, you can see that the top axis is much larger than the bottom axes. And you can sit here and try and think how many multiples of the bottom axes, typically you do want these in solid multiples, how many multiples of the bottom axes can I fit into the top? Well, I'm going to take a guess and say 3. And we can always change that if we need. You pass these into something called grid spec keyword arguments. When Matplotlib lays out multiple plots, it typically, and through the subplot mechanism, it will use what's called a grid spec. And this is essentially dividing your sheet of paper, your figure, up into multiple subsections. And then you can tell Matplotlib a little bit more about how you want to divide those subsections. So this is something called height ratios, and you pass in as many values as you have axes in rows. And so since I have 2 rows here, I'm going to want the first row, the top one, to be 3 times as large in terms of height as the bottom one. So let's go ahead and take a look at this now. All right, so we've correctly identified the spacing there. The next thing that I want to do, let's see if we can get some of the bottom data on first. I always want to get my data on first, and then I can focus on some of the aesthetics and annotations. So in order to get the bottom data going, we're going to need just a little bit more data cleaning. So let's go ahead. We have our precipitation data here, and what I'll want to do, this is cumulative on the month. So I'll need to do a resample here. And I'll do that, okay. Precip, resample. This uses the index. Since we have a datetime index, I'm just going to resample on the month. I'll call this something here. All right, and we'll go ahead and just print cumul precip. There. Okay, so once I do the resample, this should just be a cumulative sum. Let's see if this looks correct. So we can see it increasing. That's fine. We didn't have the .cumulative sum there, so that is concerning. Let's check our methods here. Resample .cum sum. And based on the method, we know that we need to, oh, is this a data? No, this is already a series, right? Good, good. Precip, just like this. And that gets me the indexer there. And let's take the sum here. So that gets me the perfect, that gets me the sum. I do want that cumulative sum though. And so let's see, what would we need to do here to get that cumulative sum? Take a look back at our data. We have that, that's good, and that's on the daily. Maybe I need to do a month start here. Let's do a dir on my resampler here. So there should be a cumulative sum method attached to this. Let's see what we have exposed to us though. Bfill count, group by and unique, yeah. Okay. Well, I know for a fact this is going to be a little bit of a workaround, but this should work. So we'll 2-frame that. Then we'll take a look at what we have after we 2-frame it. We should have a data frame here. And what I'll do here is I'll start my resampler. And then from our resample, extract out the precipitation column. Pardon my spelling. See, that should the series resampler group by. That's very strange, right? I had to do this kind of roundabout operation. I could have probably reached into the group by with a grouper there, but we got to the end goal that we wanted. We now have our cumulative sum within each month here. And let me verify this looks good. Yep. The 100 is a little concerning. That seems a little high, to be honest. So maybe I've done some interpolation incorrectly there. And so what I'll want to do here is not just look at the top rows, but let's look at the bottom, say 20. So that looks correct. Let's see. When we defined our precipitation, it was already cumulative. Of course. All right, so let's just go ahead and plot that right up then. And so we can take that. This should be a dot plot precip dot index right there. It's just precip, and then pass the values in. Let's take a look at this now. And this should have our lines. Okay, so that's looking correct to me. So now that we have our lines, let's go ahead. We'll need a fill between here. And then the color, let's check on that color. So we've plotted these lines here on the precipitation for our lower axes. Now what we just need to do is have an actual fill under, and this looks like it's the same color as the record range, so I'll just give it that same color. So this is looking solid to me. One thing that is actually quite different that I'll need to fix up here is that in my visualization, you can see that the months kind of lead into one another. We're not hitting back down at the 0 mark or cutting off to show that this is cumulative on a per month basis. So you can see that the end of March here flows directly into the beginning of April, and the end of May here flows directly into the beginning of June, right? And we don't ever hit 0 to show that our cumulative sum is resetting. Whereas with a Tufte visualization, you can see that these very clearly stop. Now, whenever it comes to Matplotlib problems, I would say, or issues that you're encountering, you can always divide them into two different categories. Is it a problem with my data, or is it a problem with the presentation of the data? And for this, we can use just a little trick for Matplotlib to not interpolate between the months. And all we need to do is actually just re-index some of our data here. So I'm going to go ahead and create a new index. And this index will grab date range from pandas. What I want to do is I want to introduce null values where we want a break in our line. And what this has the advantage or ability to do is when Matplotlib encounters a null value, it will not interpolate over it for you. However, if there are no null values, right, it will automatically interpolate over everything for you. And so we'll go ahead and we'll do 0, 0, 0, 0, 0, 1 here, just like that. The reason I'm adding 1 second is because I want to combine this with the index of our precipitation. So that's our date range, our unit, or our frequency will be our month, and our periods, we have 12 periods. All right, just like that. And you can see this is my new index here. I'm going to union this with the existing index. And by default, this should be sorted, but we'll find out. And then what we need to do here is when we plot, we just use this index. And then we re-index to introduce the actual null values where the time or where the second is 1. Just like this. And let's see if that broke apart our lines for us. It looks like it actually did, so this is looking very good. Let's go ahead and spruce up some of the aesthetics here. We want to add in vertical dashed lines. We also want to add in grid lines across the horizontal. We want to fix up our y-axis here as well, and we'll want to do that for both of our charts. Lastly, we'll want to add labels for each of the months centered between the bars, so I'll have to use both the major and the minor tick locators here. And that should get us close enough to something that looks quite good. Okay, so let's take a look at setting some of these parameters. We'll start with the horizontal lines because that should be fairly quick. Take the y-axis grid, and those lines horizontally were the same color as the background. We'll do a couple steps in one here, so we also need this on the precip.ax. And then I like to separate these just by plot there. So now let's do a grid on the x-axis, and these will have more or less a gray color. It's actually quite hard to tell what color they are from the visualization. So we'll give them a gray, and they were very heavily dashed, so we'll give that a dashed line style. Let's take a look where we're at now. Oh, I also need that grid on the lower axes, but you can see we're getting close to mimicking some of Tufte's visuals here. The grid is a little bit high up, in my opinion. We don't want it above the red bars, and clearly it is sitting above the red bars here. So maybe what we'll do is just boost the Z order of the red bars. But other than that, I think we're looking quite good. I'll just add the grids to the lower axes as well. So the precip.ax here. And you can see all of the fine-grained control that Matplotlib gives me over these things. So we'll grab our daily, and we'll just give this a Z order of 6. Z order of 5 should be the largest default Z order here. And so we'll just need to do that. Series object, no x-axis. It should be precip.ax, that's why. All right, so now our red bars are over top of the dashed grid lines. This is looking good. Now, I want to tighten up the Y limit on the bottom plot, make sure that starts at 0 and stops at 10, because that's what Tufte's visualization had, 0 to 10. So I'll manually set that, and then I'll also reinforce that with our tick locator, and then I'll fix up the x-axis ticks as well. So let's see what we can get done here. So precip.ax dot set ylim, this is 0 to 10. That should be good. And then just to enforce a correct tick locator, we want to tick every 2. We'll take our y-axis, set major locator, and then this will be a Matplotlib multiple locator. Just like that. Every 2. I'll also do the same thing for the temperature axes. This was every 10. So instead of 2, we'll use 10. This makes sure that we have evenly spaced ticks. Then we'll even go ahead and spruce up the, let's see if we can spruce up the dates on the x-axis on both. And we'll do this, multiple locator. This should be day locator, and I think that's it. And then we'll grab the date formatter as well. Okay, so what I'm going to do to mimic this kind of output here, I'm going to want to use, I'll use my major ticks to specify the start of each month or the end of each month. Then I'll use a minor tick location in order to apply the labels. So let's see if we can do this really quickly. So that should be my temp axes. Reach into the x-axis here, set major locator. This should be day locator. And we want it on the first day of every month. And then for our minor locator, we'll want this, we'll do 15. It's kind of, not every month has 30, 31 days. It's, it spans. But we'll just use 15 as a good estimate for where we want these labels to be. And then what I'll do here, x-axis sets minor formatter. And this will be our date formatter. And I'll give this a %B. That just gets us the month name. And then the last thing I need to do is actually turn on the correct ticks and labels. We want to turn off the ticks completely, which equals major, bottom equals false. And so that should turn off my major ticks on my x-axis. And then let's go ahead and turn on not the ticks themselves, but the top label top. We want that to be true. So this should add my labels to the top. Let's see where we're at, because we haven't checked in on our visualization in just a minute. This should be true. Okay, so we're actually looking quite good. We can see that we've successfully added in our grid lines. We just need to remove the ticks from the bottom, the minor ticks from the bottom, but we've set up that correctly. So this should be bottom equals false, just to remove those ticks. Then we'll do a similar thing for the precip AX. And that looks good. We don't want the major ticks at all. And instead we want the bottom as well, and we'll give the same locators as well. So this needs a lot of the same parameters. There we go. And then instead of label top, we want label bottom. Let's see if we're looking good here. Okay, so we just need to turn off the label bottom. You can see that some of the previous xtick labels are interfering there. So label bottom equals false there. I probably need that here. All right, so that should be good on that front. Let's go ahead and add the title. See if we can get this into a mostly working state. I'll remove the top and bottom spines from both these axes. I think we can go ahead and do that. So I can set this as a default kind of global parameter, take my spines, turn off the top and bottom. And then we'll go ahead and add our title. And I'll show you just a quick little trick for adding the title into the appropriate position. So if we just take our precip AX and use the default kind of set title here, NYC's weather in 2003. I can specify this location parameter to flush it to the left-hand side, but I do want to note just one very small thing. When we do this, and this should be temp AX, for our temperature here, you can see that our title, it is left justified, but it's left aligned against the spine itself, whereas in Tufte's visualization, it's left aligned against the left-hand side of our tick label on the y-axis. So instead of doing that, we're actually going to want to grab the bounding box. This is a way of getting the rectangle that wraps our entire axes. Then what we'll want to do is we'll actually want to place our annotation, or the text object, against that bounding box. And we'll want to blend this transform. This is where it gets a little bit tricky with Matplotlib. From matplotlib.transform, import blended transform factory, because we want to place this all the way at the top of the axis, but we also want to use this bounding box. And this will be in absolute figure units or points. And so we'll have to work with both of these transforms, but I believe this should be a transform of this blended transform factory. And our X units will be an identity transform, so we'll need to grab that. The identity transform is how we can plot in just kind of raw units. Raw kind of points units that should specify. And then we want on our Y, we'll want our axes.trans axes there. Then we'll do our axes text. Our X will be 0, our Y will be 1. And let's just add in some and then we specify our transform. Let's see, identity transform, the X should not be 0, this should be our our bounding box, the left-hand side of our tight bounding box. And then this is S, just like that, transform equals transform. That looks good. Okay. from matplotlib.transforms. Blended transform factory, just a typo there. Transform, S-O-R-M. Very good. And then this should be our temperature AX right there. That's good. Temp AX. And we'll see if this transform gets our title into the correct place here. So it looks all like it's just there. We'll need to offset it above our top tick labels, and we'll need to left align it. And we'll also set the size, right? Extra large here. And then I would usually go about this by adding, right, just like a padding in units, or maybe even grabbing the bounding box right at the top of our type bounding box here. But we're already down this path, so this is looking good, so that HA should be left. And we can see that there might be some recomputing just of the bounds here, so we need to work around that, but we are getting fairly close. We have a flopping on our axes, so we just need to set our axes to be tight there. X equals 0, that's probably on our precip AX. Just like this. And so we would need to play around with this title a little bit more, but you see the idea of how we can get something aligned to absolutely any position in Matplotlib. And this unfortunately does take us to time. There's so much more with this visualization that I would want to do. We need to add things like the legend, and we need to specify our tick formatters, which would not really take that long at all. But you can see that Matplotlib really gives you an incredible amount of flexibility. Here we just explored some of the, in my opinion, some of the advanced features, right? Things like the blended transform factory, or setting all of your y-axis and x-axis parameters in a manual fashion instead of deriving your own ticks and tick locations. The thing that I really want to draw your attention to is that we were able to get all of our data onto the chart in about 15 or less minutes. Getting your data onto a visualization is the most important thing, and honestly, it doesn't take that much code. And so what I want to orient you to is once you're able to get your data onto a chart, you're able to visualize it. If you want to take those data and take them further, that's when you focus on the aesthetics. Always try and get your data on first, because the aesthetics can always be changed or updated. But this does take us to the end of our time together. If you want to see the code or even more code and materials, you can always ask on our Discord. We're more than happy to provide code materials and links and references for you. It's been a lot of fun, and thank you all for attending, and I'm looking forward to seeing you all again next time.